you are asked to determine the acceleration due to gravity, g, using the simple pendulum shown in the figure. The oscillating length of the pendulum could be adjusted. Part A. Name the additional measuring instruments and items necessary to carry out this experiment. We know that when finding acceleration due to gravity by using the simple pendulum, equation is T equals 2 pi root L over G for the small oscillations with small angles. When finding gravitational acceleration by using this simple pendulum, if we are using a graphical method, they have given that oscillating length could be adjusted. It means we have to change the length. Then we can change the length and we can get it as the independent variable. We have to draw a graph with a physical quantity related to x as the x. Then we have to measure period. It is the dependent variable. We have to get a physical quantity related to t as the independent variable, and we have to draw it in y-axis. Then we have to measure the length and time. Therefore, we have to write additional measuring instruments, meter ruler and stopwatch. We have to measure time by using stopwatch and meter rule, length by using meter ruler. The next one, additional items. These are additional measuring instruments. Additional items. We have to use a reference pin as additional items. We are placing reference pin at this place, and we can count number of oscillations by using this reference pin. It is the additional item we have to use for the practical. Then part B, 1. Write down an expression for the period of oscillation t of the simple pendulum in terms of oscillating length L and acceleration due to gravity g. We have to write this equation. It is part B. T equals 2 pi root L over g. B part 2. This is B part 1. Now B part 2. What is the exact oscillating length L in the experiment? We have to measure the height between center of gravity of object and this hanging point. Then exact length is height between center of gravity of pendulum bob and hanging point. Then part C1. Part C1. Underline the correct angle of inclination at which you release the pendulum bob before it starts oscillation. We have used this equation for the practical. We have derived this equation by using a hypothesis. It is valid only for small angles, only for small angles of oscillation. Therefore, angle should be less than 5 degrees Celsius for this practical. Now you can get a distance, measurable distance for this pendulum for 5 degrees angle by using a large length of the wire. When increasing length, we can oscillate simple pendulum in a long range. Therefore, normally we are using this pendulum length about 40 centimeters. Then see part 2. Now you can avoid error in occur the number of oscillations when starting the how can you avoid error in counting the number of oscillation between starting the stopwatch. We have to start the stopwatch when the pendulum bob is passing this reference point, and then we can count number of oscillations as 1, 2, 3 like this. Then you can write start the stopwatch at reference point. And count the number of oscillations. We are using this point as the reference point because of there is a maximum velocity, maximum speed for the pendulum at this stage. When the speed is maximum, the error of time measurement is minimum. Then part 3, how do you verify the oscillations of the pendulum occurs in a vertical plane? You have to check that the pendulum is moving, is not moving sideways. We have to consider only the movement in this path. We have to oscillate the pendulum only in this direction without sideways. Then we can write answer for part 3. We have to oscillate pendulum without moving sideways. In part B1, rearrange the expression in part B1 above in order to determine the acceleration due to gravity G by plotting a suitable straight line graph. I will write the equation. T equals 2 root L over G. Now, X is the independent variable, which is we have to write it. We have to draw it in x-axis. T is the dependent variable. We have to draw it in y-axis. But in this equation, there is a square root. We can't draw graphs with we can't draw graphs with square root values. Therefore, we have to get the square of the equation first. Then I will square all terms. T squared equals 4 pi squared into L over G. Now we can get T squared for the y-axis, L for the x-axis. Y equals mx. Then considering x and y physical quantities, we can draw x 1 over x squared for the x-axis, but we can't use square root values. For the y, we can use y 1 over y squared for the y-axis. Then part 2, calculate the acceleration due to gravity g using the following graph. Giving your answer in SI unit. Take 5 squared as 10. They have given a hint. Do not simplify the value of gradient. Now we have to select correct coordinates from the graph. Then getting coordinates to find the gradient. There are some rules I will explain. First one is considered coordinates should be between mark points. If these are mark points, we have to consider coordinates between this minimum and maximum point. It is the first one. Then second one, we have to select coordinates such that we can read x and y values clearly. It is the second point. Then third point, we can't get marked values in the graph. It means we can't get marked points when finding gradient. Then fourth point is we have to select 2 points with maximum distance. Maximum distance but within the mark point. Then you can remember we have to select 2 points such that points are within the range of these mark points. Second point is we can't select mark points. We have to select another 2 points. Third point, we have to select 2 points such that we can identify clearly x and y value. Fourth point, we have to select 2 points with maximum gap between 2 points. According to that 4 conditions, we can select 2 points from the graph. I will write the coordinates, then you can check coordinates of corresponding points. When finding first coordinate, we have to select a readable point from this final point. Then we can get 89 3.75, and then we can observe from this side a readable point, and we can select 43 1.75. Now I will find the gradient by using these 2 points. Gradient equals difference of y divided by difference of x. When getting difference of y, we have to subtract y values 3.75 minus 1.75 divided by, then getting difference of x 89 minus 43. But values in y-axis is given in seconds. They have given square seconds. It is SI unit. We can get this one as the difference of y. But x-axis is given in centimeters. Therefore, we have to convert it to SI unit, meter, 10 to the power minus 2. We have to convert this centimeters difference to meters. They have given that do not simplify the value of gradient. Therefore, we can consider this one as the answer for part 2. And same part, they have asked calculate gravitational acceleration. This is the gradient. Now we know that gradient is equal to this part, 4 phi squared over g. We have to find g. Phi squared value is given as 10. Then we can substitute 10 as the phi squared value. Now I will simplify it. 3.75 minus 1.752 divided by 9 minus 3, 6, 8 minus 4, 4, 46. Into 10 to the power minus 2, I will bring it to numerator as 10 to the power 2, it means 100. Equals 4, 5 squared 10 over g. Now we can cancel out 1, 0, 2 divided by 2, 1, 23. Then I will subject g value. 4 into 23 over 10. 4 into 3, 12, 1 remaining. 4 into 2, 8 plus 1, 9. 92 divided by 10 means 9.2. Gravitational acceleration in SI unit, meters per square second. Then part E, consider the conical shaped mass shown in the figure. Write down one advantage and one disadvantage of using this conical shaped mass as the box instead of spherical mass. If we are using spherical mass, we can't identify the time passing this pointer correctly. It is easy to find the time by using this conical shape. Then we can get advantage, reference point, reference pin could be placed easily. It is the advantage. But the disadvantage is when measuring length, we can identify center of gravity of spherical object clearly because of it is the midpoint of sphere. But we can't identify center of gravity for the conical shaped object. Therefore, we can write disadvantages. It is difficult to locate the center of gravity of the bomb.